We're ready to take a look at these swell pedals now, or expression pedals. The one on the left, as we look at them here, is the crescendo pedal, and the one on the right, as we look at them here, is the swell pedal. And they have these multi-way cables coming out the back of them, which are actually 8 cores. So I've no idea how these are going to be wired inside yet. They may be light bulbs and light dependent resistors with a shutter, or they may be simple potentiometers with a load of extra cables, or they might be Hall effect magnetic type sensors. So we don't know what they are, we don't know how to connect up to them yet. So what I'm going to do, they seem to be held in with a couple of screws at the back here. There may be extra fixings at the front, but we'll start with what we can see. So I'm going to remove the screws, remove the pedal, get it up on the bench, and then we'll take it apart, see what's inside it, how it works, and how we're going to connect to it. Got the swell pedal on the bench now, or one of the 2 pedals. This is actually the swell pedal, and we've got this wiring on the back, which is actually just a plug and socket arrangement, which is quite good, mainly because this cable is not going to be long enough to reach up to where the analog control inputs are going to be on the main board. However, we need to work out how this thing works. So it looks as though, looking down the end here, that's probably a shade. I'm guessing that one side is going to be a light bulb, the other side is going to be a light dependent resistor. And looking underneath the thing, we've got this little panel here that looks to be removable, and I'm guessing that that's where those 2 components are going to be. So I'm going to undo these screws, open this up, and see what we've got inside. So this is in fact a light dependent resistor, but it's not a light bulb. There's a little LED in there, so I'm just going to try and zoom this in, if you bear with me for a moment, and see if we can get a better view of that for you. Okay, so there we are. So you can see that on this side there's a little red LED, and then there's an opening slot in this. So the further we advance the pedal, the more light is allowed to come through, and then as we retard the pedal, there's less light allowed through. And then on this side, that's a little light dependent resistor there. So we can trace the cables back, or the tracks back to the circuit board to see what happens. So we've got these 2 connections, trying to think how best to show them at. Right, so those 2 connections there that connect across to the light dependent resistor, and then this side we have got a whole bunch of connections between the LED and the outside weld. So that goes to one side of the LED, so that's that connection there. The other side looks as though it probably goes to a transistor or something, maybe a voltage regulator, not sure. So what I'm going to do next, just to make certain, if we had direct access to this side of the LED, then life would be easy, because that only needs to connect to our control voltage, or our supply voltage, 5 volts, with a resistor. But they're probably doing something clever here, so I'm going to undo these 4 screws, and we'll pop this board out and see what's on the other side of it. Okay, so here's the board removed from the swell pedal, expression pedal, call it what you will, and so we've got a few bits and bobs on the other side of the board. So this is the light dependent resistor that we spoke about earlier. You can just see it there, and then we've got this little LED, and then on this side we've got a transistor which looks like a 2SC550, don't know what that is yet, I'll look it up in a moment, and then we've got a couple of 680 ohm resistors, and we have got a 4.7k potentiometer. So my guess would be that this basically sets the brightness of the LED, and we're going to have an input on here which may have been 12 volts or 5 volts, I'm not certain yet. So a little bit of experimentation required, and just quickly work out how this is actually wired up. So obviously we can see from the back here what connects to what, at least we can if we get it out of the light. So one side of that potentiometer goes to this connection here, and then along to one side of the LED, so almost certainly that's going to be the 0 volt line. Then we've got the other side of that potentiometer, which goes along to one of those 6, or both actually, of those 680 ohm resistors. They're interestingly both in parallel. 680, so that's to give us 340 ohms. And then that goes to, I imagine that's going to be the base of the transistor. No, sorry, that's going to be the base of the transistor, because we've got our input voltage across this potentiometer here, that's across either end. The wiper of the potentiometer comes out to here, so that's going to be the base of the transistor. This is going to be the collector, and this is going to be the emitter, I expect. Or it could be the other way around. If it's not an NPN transistor, it's possible that it could be where this is our supply, which goes through, and in fact this may turn out to be 0 volts. So I'll look up, see what that transistor is, and we'll go from there. Okay, so I've taken a look at this little circuit board now, and basically this is what the circuit of it is. So we've got our plus volts coming in here. There's a 4.7k potentiometer, as I pointed out on the circuit board. That's basically across the supply, and then the wiper of that, so that can be adjusted between full voltage and 0 voltage. That goes directly to the base of the transistor. The LED is in the collector circuit, and then the emitter circuit has got these two 680 ohm resistors in parallel to give us 340 ohms back down to 0 volts. So the only question we've got now is, what is this supply voltage supposed to be? Should it be 5 volts? Should it be 12 volts? Should it be something in between? And presumably this is adjustable so that we can set the correct current through this LED. Now that's where the guesswork comes in, because we don't know what this LED is, there's no markings on it, but what we have got, if we take a look at it, so let's move this out of the way. I've got this working now, by the way, so if I shield that you can see the LEDs on. In fact, if I just switch it off, so there we go, you can see that's working. It's currently on a 5 volt supply, and the reason that I've gone for that is this is quite an old LED. The organ was made in 1993, and looking at this LED, it's a 3mm red LED. I don't think it's infrared or anything like that, because in those days they were usually encased in metal, so it's just an ordinary plastic LED. So it's almost certainly going to be a gallium arsenide LED, which runs at a much lower current than the modern LEDs of today. So I've just measured this. There's about 3 volts across that LED with this on 5 volts set up as it is. It's just glowing, it's not overly bright. I did try turning the voltage up, but the current goes up very quickly when you do that, so we don't want to damage this LED because we're going to use it. So that's it really. We know that we're going to supply this thing with 5 volts. This pin, where are we? That pin there is the plus 5 volts pin. The next one down is 0 volts, and then that's all we need to care about. We're not bothered about the others. And then on this side for the light dependent resistor, we got these 2 pins here across the light dependent resistor, and again it doesn't matter, it's only resistor, so they can be either way round. So that's all we need to know. I can put this back together, and just to make it a bit easier to see what we're doing, I'll do another little drawing of how we connect to this and what the connections are going back to our controller board. Okay, so I've connected this swell pedal up to a power supply now, and also to our meter, so that we can measure the resistance of the light dependent resistor inside. So basically you'll remember that inside this thing we've got an LED on one side, and then on the other side we've got this light dependent resistor. So the LED is being powered, and the resistance of the light dependent resistor is being measured here. So with this in the fully open position, we can see that the resistance is 18.5k, and then as we close that down, the resistance drops to 3.3k. So we know that open 18.5k and closed 3.3k. Now we need to wire this up into our organ, into the system, so that we get a sensible output voltage which can be read by the analog input of our control board. So we know that we're going to be supplying 5 volts to this resistor network that we've got to make up, basically. So our analog input is expecting to see somewhere between, on this input to it, expecting to see somewhere between 0 and 5 volts. And so what that equates to is that if this was 5 volts, then it would send a MIDI control change of 128. Well, control change 7 with the value of 128. Control change 7 is volume, and 128 is the highest value that it can send. And if this was 0 volts, then the encoder would send control change 7 with a value of 0. And that's how it works. So if this was halfway through, if this was at 2.5 volts, then the encoder would send a control change 7 with a value of 64. So that's how this works. So what we need to do is to look at these values and work out what other value of resistor we need to put with the resistor, the light dependent resistor inside here, to get a voltage that will approximate the maximum we can get when this is fully open and the minimum that we can get when it's fully closed. So the first thing that's worthy of note, or that we need to know, is that as we open this, so as we increase it by pushing our foot down on there, the resistance actually increases, because some of these work the other way around, that as you open it the resistance decreases. And the fact that the resistance increases, that tells us which position in this little voltage divider network our light dependent resistor needs to be. So, just to explain how this network works, just in case you're not familiar with these, because I have had quite a lot of questions about this actually over the time that we've been doing this, and that is that if you put 2 resistors in series like this across our 5 volt supply, then it basically forms what's called a potential divider, a voltage divider. The easiest way to think of this, if there's just 2 resistors, is as a percentage divider. So if this resistor was 10% of the total and this resistor was 90% of the total, then we would have 90% of the available voltage would appear on here. So that'd be 4.5 volts. I think. Anyway, if you reverse it and do it the other way around, so we put 10% here of the total resistance and 90% of the total resistance here, then you'd only have 10% of the available voltage coming out here. So that would be half a volt, because 10% of 5 is 0.5. So that's basically how this works. So if we wanted this voltage to increase as we open our swell pedal, then the light dependent resistor needs to go in this position here. If it worked the other way around, such that this resistance decreased as we opened it, then the light dependent resistor would need to go here. So already we know that this is the light dependent resistor inside this swell pedal. So all we need to do now is work out which value we need for this resistor. So taking our 2 extremes, as we know, when it's open it's 18.5k, when it's closed it's 3.3. So we need to pick a value that's going to give us a reasonable voltage swing. So for example, when this is 3.3k, if we were to put a 3.3k resistor in here, then they would both be the same, so it would be 50% here, 50% there, so we'd get 2.5 volts out of this connection here, which is too high really, because when it's fully closed, obviously we'd want a lot less than half. So we could say, okay, well 3.3k is not enough, let's put in 33k. Well, that would give us half a volt if we did that here when it's fully closed. But then of course the problem occurs is when it's fully open, because if you've got 33k in here and only 18.5k here, then you're only going to get about 2.5 volts when it's fully open. and that's no good either. So we probably need to go somewhere between the two, and I think a good value, or the best value we're going to get, is going to be around 10k, and that should give us something half reasonable. So if we choose 10k for this, then this one, when it's closed at 3.3k, we're going to get 1.2 volts out of here. And when it's open at 18.3k with a 10k resistor in here, we're only going to get about 3.5 volts out of here. So our voltage swing is going to be 1.2 volts to about 3.3 volts, something like that. So it's a lot less than 0 to 5, but at least it is proportional to what's happening with our swell pedal, and because of these resistances being quite close to each other effectively, so some other types of light dependent resistors will go up into the hundreds of Ks, so it could be 180k or even 250k, and when it's closed it might come down to about 1k, so you can get a much wider swing than you can with this particular setup. So what we're going to do, this will send MIDI values, whatever they're going to be, nowhere near the full amount it could be, but it's going to send somewhere, I suppose, in a change of about 50 to 60, something like that. So our control change 7 is likely to vary between about maybe 30 and about 70, something like that. But luckily, in most of the virtual organ software packages that are out there, you can tell it that that's the range that's expected, and it will do the maths and multiply that up for you, so that the pedal works with its full amount of travel. And that's certainly the case in the software that we're going to be using. So that's the next thing to do then, is to include a 10k resistor into this somehow. Now normally in these cables here, when we connect them to our encoder, I would put a 10k resistor sort of between the 5 volt supply to this thing, but I'm wondering whether it's going to be easier, and probably not much neater, to actually put it inside the swell pedal, because when we looked at that circuit board a moment ago, it's quite big, there's a lot of room on it. There's also a whole bunch of unused connections on this cable coming out of it. So I think what I'm going to do is find a way to incorporate this onto that board, and then this is going to make things much easier to wire up in the long run. So I'll do that next, and then I'll show you when that's done. Okay, so I've removed the circuit board again from the swell pedal, and just to remind us what we're aiming to do, this is the light dependent resistor here, so that's this little component with these two connections there, and those two come back to these two connections on the plug. And what we need to do is to add a 10k resistor from one side of the light dependent resistor to 5 volts. So looking at our little board here, this top connector here, this is number 1 from the main 9-pin connector to the outside world. This top connector doesn't go anywhere, it just comes to this copper pad here that's not connected to anything else. So if I connect a 10k resistor between this point here on the light dependent resistor and this pad, then that gives us exactly what we need. So then our connections will be this point here, which is one side of the 10k resistor, so that's going to be our 5 volt point there. So it's going to be pin 1, so we can write that on here. It's going to be pin 1, and then this connection here, which is 2, 3, 4, pin 4, is going to be the other side where the two resistors join. So that's this point here, so it's going to be pin 4, so we can write that on here, pin 4. And then the other side of the light dependent resistor, that comes down to here, and that's pin 5. Just get that back into picture there. So the other side of the light dependent resistor comes down to here, it's pin 5. So we can write that on here. So then it all becomes much more easy to connect up to the outside world, because everything is easily connected on here, and we can just have these wires going directly to our analog input on the encoder. We don't need to worry about messing around trying to incorporate resistors into the actual wiring. So I shall do that now. Just pop a 10k resistor in there, show you that quickly, put it back together, and then we'll see how it works. I've added the new resistor now. This is our new 10k resistor. So what I did, this is the way around we had it before, so keep it the same way around. It's connected between this pad, as we said, which goes along to pin 1, and to the other side of the light dependent resistor. Now, to keep things nice and neat, I could have just soldered the resistor across on this side of the board, but really all of the components should live on this side of the board, so I just drilled a couple of small holes in the right place. One of them very close to this connection, so I could just bend the lead over and solder it on, and the other one in the centre of this pad, so the lead just comes through and it's soldered on there. So that's the modification complete now to our board. So we'll pop it back into the swell pedal and see how it works. I've put the swell pedal back together now with our modified circuit board inside, and I've connected it up to our power supply and also to our meter, which is now measuring volts rather than resistance. So if I switch the power supply on, the pedal's in the fully closed position right now, and we've got a reading of 1.31 volts on our output. That's at this point here. So we've got our 5 volts across here, the pedal's fully closed, so this resistor is about 3.3k right now. We've got our 10k resistor in here, and we predicted 1.2 volts and we've got 1.32, so not a million miles away. So as I open the swell pedal, that's fully open now, and as you can see we've got 3.55 volts and we were expecting 3.3, so pretty much achieved what we were aiming for with that. And as I said, the virtual organ software can cope with this, because this is going to give somewhere between I imagine about a value of 30 to 70, 80, something like that. So that should be just fine. So I'll put the swell pedal back in the organ now. This multi-way cable isn't long enough to reach up to where the analog input's going to be on the main control board, so I'll have to figure out something for that. I may just extend it using, we only really need 3 cores now. We've got plus volts output and 0 volts as is shown here, so plus 5 volts, 0 volts, or ground if you prefer, and pin 4, so I only really need 3 core cable. So I might swap this out or just cut it off and solder it to 3 core or something like that, but something that's going to be long enough anyway to reach up to our analog input on the control board. I'll do the same modification to the other pedal, which is the crescendo pedal, and again get a 3 core piece of cable coming back from that. I shan't bother to film any of that because it's going to be exactly the same as this, but when that's all done and everything's back in, I'll show you the thing connected up. I'm going to end this video here because there isn't much more to add. Changing that out for a 3 core cable really isn't very exciting. There's no point in doing that on video, and connecting these to the analog inputs. We haven't got the controller installed in there yet. We've only got the various interfaces, so I can't do that immediately. So I will show you this connected at the end when we look at the final thing with the controller board connected, or installed I should say, and then these connected to the controller board. So that's the end of this video. I hope it helped explain a bit about how we deal with these types of pedals where we've got the LED and the resistor with a shutter in the middle, but hopefully it was helpful anyway.